There are many reasons the body may want a cell to die, and just as many reasons why it wouldn't. Take, for example, a sick cell. A cell could be sick because of an error in its DNA. It may not produce enough proteins, or maybe it just didn't have enough oxygen. In some of these situations, the cell will die, and in many others, it won't. So why is that? Why is it that you recover perfectly from a small bout of frostnip, but a bad frostburn can lead to permanent damage? The reason for that is anti-death proteins. Cells produce anti-death proteins in order to combat low-level stresses they receive on a day-to-day basis. However, if any stress becomes too large, it's able to overcome these anti-death proteins and causes the cell to die. Let's say you're going for a run. Part of the way along, you're going to become short of breath, and your muscles are going to start to feel sore. At this point, some of those cells are deprived of oxygen. At this point, some of those cells are experiencing a stress that could result in them dying, but they don't. Let's contrast that directly with a cancer cell in a growing tumor. A cancer cell in a situation such as this is under constant stress. It doesn't have enough nutrients, it doesn't have enough oxygen, and it doesn't have enough growing space. So how then does the cancer cell survive? These are obviously a lot of stresses. Cancer cells upregulate these anti-death proteins in order to avoid the stresses they're experiencing. Now, under these same conditions of stress, cells are actually less able to produce proteins of any kind. So again, I'll ask, how come then cancer cells don't die? One mechanism by which this happens is the eukaryotic protein initiation factor 5b, or EIF5b. Because it's a mouthful, I'll probably just call it 5b for the remaining minute. The protein 5b has been studied by our group over the last year. We've discovered in our recent publication that 5b assists in the production of many anti-death proteins. Now you may be wondering, if you already know that it does that, then what am I studying? What I'm trying to look at is the complete collection of proteins which are regulated by 5b. While we were able to verify a select few anti-death proteins, I really want to look into all of the proteins that are regulated, especially all the anti-death ones, in order to assess the effectiveness and possibility of using 5b as a cancer target for combination therapies, such as with current chemotherapeutics, such as temozolomide and TRAIL. Thank you.